Hi guys, welcome back to another video. Today we're going to be going over the AMC 2017 problem number 18. And as we can see here, this is a geometry problem and we are asked to find the area of the quadrilateral provided. And so the details are, we know that angle BCD is a right angle, right? So we can just mark that BCD is a right angle. AB is 12, BC is 4, CD is 3, AD is 13. And we have to find the area of quadrilateral ABCD. Okay, so the first thing you want to do with geometry problems is make sure you write down all the information you're given, right? Because geometry problems are like puzzles where you get some information, now you have to kind of work your way up and find what the question is looking for. So for example here, if this quadrilateral ABCD is not a regular polygon or anything that we know how to find the area of, right? It's not like a rectangle or a square or a trapezoid. This is called an irregular figure. And your strategies for irregular figures, any type, you really want to express that figure in terms of figures that you know how to solve for, right? So a lot of times there's two main techniques we can use, right? So if you have any type of irregular figure, you can either split it up into smaller parts of which you know how to find the area of, right? So for example, if we have something that looked like this, right, that we don't know how to find the area of that directly necessarily, but if we split it up into, say, these two triangles, and if they're both like right triangles, we can find the area of this region and add it to the area of this. So that's our first strategy, breaking it up into smaller parts. Our other strategy is to express it's a very similar strategy, but here you extend lines or you draw in auxiliary lines is what they're called to get a bigger shape and then subtract out unwanted regions, right? So if we go back to our example, if we have the same type of diagram, so we have something like this. So if we have something like that, rather than splitting it up, what we could do is extend these lines, find the area of the big triangle. So if we outline this in red, it looks something like this. So find the area of the big red triangle, and then subtract off this small red triangle, and that would give us our desired region. So these are pretty much the two main techniques you'll ever need for irregular figures. And now looking at the diagram that they give us in the problem, we see our first strategy doesn't really help because there aren't any obvious ways to split it up into areas that we know how to find. However, if we were to draw in DB, right, so say we draw that in with a dotted, or say we do red line, DB, now this might look more approachable because we know BCD is a right angle, so we've just created a right triangle, and right triangles are our best friend in geometry. So if we look at BCD, and let's kind of expand this. So you have this point up here is D, B, C. You know that's 3 and this is 4. So if this is a right angle, hopefully everyone knows the Pythagorean theorem, which just says in the right triangle, a squared plus b squared equals c squared, where a and b are the legs and c is the hypotenuse. And plus 3, 4, the most common Pythagorean triple is just a 3, 4, 5 triangle, right? So we know DB is 5. 9, 3 squared is 9, so 3 squared is 9, 4 squared is 16, 9 plus 16 is 25, and 25 is just 5 squared. So basically we know BD is 5, right? So we kind of draw it in here. Now we have, if we look at triangle ADB, you might recognize the numbers 5, 12, and 13. This is actually another right triangle, right? Because 5 squared plus 12 squared equals 25 plus 144, which is 169. And that's just 13 squared. So we know that triangle BDA is a right triangle, and angle B is the one with the right angle, right? So now right triangles are our friends, right? Right triangles we know how to find the area of. So what is the area of BDA? If we start there, That's just 1/2 times 5 times 12, which is 30, right? So this is our entire region, BDA. And if we want the quadrilateral ABCD, right, if we kind of just quickly shade it in, it looks something like this region right here, we realize we need to take out the area of our smaller right triangle, which is given by BCD. So what is the area of BCD? That's probably helpful. It would be 1/2 times 3 times 4, right? That's just 6. So this means that our desired area, the area of the quadrilateral, would be the difference between the two triangles. So it'd just be 30 minus 6, which is 24. And 24 would be our final answer. So we'd circle it and move on. And that marks the end of this video. If you have any questions, be sure to leave a comment. And if you enjoyed, make sure to leave a like or subscribe so you don't miss out on any future uploads. Thanks to everyone who joined, and I will see you again tomorrow.